Good evening, everybody. My name is Rob Godfrey. I work at the FT, and I've worked there for quite a number of years now. My background is in sort of software development and software architecture, and I run a small team at the FT, and we're called sort of Cloud Enablement. And what we do is we try to make AWS and our other cloud platforms easy to use for our delivery teams. So one of the things we do is we manage our AWS account, and what I'm going to talk about tonight is really how we do that, and specifically how we use sort of continuous delivery techniques to essentially manage our accounts and the infrastructure we drop into them. So a little bit of background about sort of the FT and AWS. We started using AWS in about 2013, and after some successful pilots, we began migrating workloads quite aggressively into AWS from 2014 onwards. Today, we're running a lot of our estate in AWS. We also use quite a lot of Heroku, but today there's about 600 plus workloads. It's a bit difficult to count, but somewhere around that number. And we're running those in about 50 accounts. So a reasonable investment, shall we say, in AWS. And one of the things we did a couple of years ago, 2016, we were only running in about 10 accounts, and we'd grown and migrated workloads very quickly that we hadn't really paid attention to how we were evolving our accounts and the architecture of those accounts. And so we dug ourselves this hole where we had some accounts that, in our eyes, were quite large. So we had lots of instances in there, lots of stuff in S3, lots of network traffic in and out, and also lots of keys and users all accessing that stuff. So it wasn't, we hadn't really kind of designed that properly. And we essentially sat down and thought, we can't carry on like, obviously that poses various security and other issues. And we kind of sat down and effectively came up with a strategy for what we wanted to do next. And effectively that boiled down to we needed to migrate to more but smaller accounts. And really the motivations I mentioned were security primarily, so thinking about least privileged access to data and also to resources, and also thinking about reducing the blast radius in the event of any sort of security breach. And in addition to that, we're also battling with managing costs and managing resources and ensuring that we wanted to see clear resource ownership. Ideally, that would lead to better cost attribution, so we knew who was spinning up resources, who we could attribute cost to. And also, we were finding in those large shared accounts that there was lots of, shall we say, cruft building up in those accounts, and people weren't tidying up. So we'd hoped that by moving to these smaller accounts, that we would see improvements in the security and those other sort of housekeeping areas. So some of the challenges we had were around, so that time where we didn't really have any investment in automation or testing. To provision new accounts and to update the sort of baseline configuration of account is all sort of manual. And as a result, we had lots of inconsistencies across those accounts. And I'm pleased to say, and so basically, my background is in sort of software development, software architecture, as I said, and we use continuous delivery a lot across the FT for deploying applications. And when we're thinking about how we're going to tackle this problem, we're thinking, okay, let's take those techniques that we use in the software space and apply them to the infrastructure space. So thinking about keeping all our infrastructure, defining it as code, keeping it in source control, creating repeatable processes for deploying that stuff out to our accounts, investing a lot in automation, and also testing to ensure that we've built quality into those sort of processes. So I'm pleased to say with today, to sort of skip to the kind of the end point, most of our, all of our sort of baseline infrastructure that we drop into our accounts is managed in source control. We package a lot of those resource definitions into some reusable modules, and I'm going to talk a bit about that in a minute. We can then leverage those modular kind of definitions of infrastructure and compose those modules in various ways to build out our accounts. And we've got automated pipelines for release and deployment, and lots of investment in tests to ensure that what we're releasing actually is what we expect to release. So what I'm going to cover today is this kind of concept of reusable modules for sort of defining infrastructure, how we then essentially compose those modules together to provision our accounts, and then a bit about at the end about some additional bits we've added on in terms of some tooling to help us actually manage lots of accounts. So I'll start off with this notion of reusable modules. When we spin up a new AWS account, we want to drop a bunch of capabilities into our account. So it includes things like setting up federated SSO to allow our developers and engineers to access the accounts through the console, configuring various auditing and governance capabilities using CloudTrail and config. We use a tool called Cloud Health to visualize costs for across our estate. And so there's some roles and stuff we have to set up to allow Cloud Health to pull data out of the accounts. We set up VPC networks, and we drop intrusion detection stuff, and there's a bunch of more stuff we put in. So this is kind of a handful of the modules. We actually have about 16 or 17 modules we deploy in as kind of the base layer for an account, but it didn't fit on the slide, but they're the sort of more interesting ones. And a module is really, they're just a wrapper around one of those capabilities. So that's the key thing for us. And the reason for that is actually a lot of the modules are managed by different teams within the FT. So our CyberSec team will manage some of the modules. Our kind of the operating system team will manage the EC2 patching systems and that sort of thing. We manage quite a few of them. And really, the challenge we have is we've got these logical modules, and we need to be able to deploy them out to many accounts in various configurations. So today, I think we've got about 15, 16 modules, and I think we're up to 53 accounts now. And so that's the challenge, is basically how do we essentially deploy those modules out to many accounts. So when I'm talking about a module, I haven't really explained what that is yet. So a module in our sense is, we use Cloudformation for defining resources. A module contains one or maybe a handful of templates. Typically, there might be variations that are required, or sometimes there's a need to separate templates. So typically it's one, but sometimes it's a few. If those Cloudformation templates define any sort of Lambda functions, we also put the Lambda source code within the module. And we also have a collection of test assets that we use to verify the infrastructure that we're deploying, and also the Lambda source code. So a few guidelines we use internally for thinking about modules. So again, focus on a single capability. Ideally, we want them to be standalone and essentially dependency-free. For many modules, that's achievable. For some, it's not. So quite a lot of our modules depend, for example, on knowing what VPC they need to deploy into. So we get some into module dependencies. We want them to be able to be reusable in a sense, so they should be deployable to any account and to any region. So that in terms of what you're doing inside the Cloudformation templates, you need to be aware of that. And I guess the big one is there are global services like S3 or account-wide services like IAM, where quite often you run into, if you're deploying the same template multiple times, you will quite often bump into resource name collisions. So an S3 bucket, for example, has to be unique. So this is a little Cloudformation snippet in YAML, and just defining a simple bucket. To avoid collisions, in this case, we're expecting this bucket to only be deployed once in any given region. So we're using Cloudformation pseudo variables, account ID and region, to essentially disambiguate that particular bucket from another execution of this template in some other region. If you want to do things multiple times within a region, you might have to use in other ways of disambiguating. There's also a stack ID pseudo variable that you can use as well. So we have our sort of module. So that's the source code repository. So we have Cloudformation templates and Lambda source files and test assets. And with each of those modules, we have a corresponding pipeline. The pipelines are all templated, so it's not a unique pipeline per module, but it's an instance of a sort of a templated pipeline. And we run, so any change to any of those Cloudformation templates, the Lambda source code or the tests, will trigger a new instance of our pipeline. And it's fairly simple. We have a validation stage, a test stage, and a publish stage, with the expected outcome being that we publish some sort of immutable version of that module. And we just publish that up to S3, and we just have and I'll show you, we have a sort of a convention-based approach for how we publish those assets out. So in terms of validation, Cloudformation has a command called validate template. It allows you to check for your basic JSON and YAML syntax. It will check resource type, so it knows that AWS S3 bucket is a valid type, and it knows what's not a valid type. And it will also check some of the intrinsic functions and parameters that get passed to those. However, it doesn't check property names, which I think is a pretty serious limitation. So for all your resources, when you're defining them in Cloudformation, you say the type is a bucket, and I've got a set of properties that I can supply to that. Unfortunately, validate template doesn't really do anything for you in that space, and it also obviously doesn't then check the types of those properties. Why? I don't know. However, CFN-lint is a quite neat little open source library that gives you a lot more. It's developed by an ex-colleague called, or maintained by an ex-colleague called Marty Sweet, and it does do this detection of property values, sorry, property names, and checks those sorts of things. AWS actually publish effectively a schema for all the Cloudformation resources, along with all the properties and all the types of those properties and whether they're required or not. So why they don't use it in validate template, I'm not sure. But CFN-lint is what we use, and it gives us much better it picks up many of those sort of annoying sort of typos or missing property type issues early on in our pipelines. In terms of testing modules, the way we approach that is we take our templates and we just deploy them to a sandbox account that's specifically stood up for just this purpose. And then we launch the stack, wait for the stack to complete, make sure it completed successfully, and then we can use, there's a describe stack API endpoint that we can use to essentially pull back what Cloudformation thinks it's deployed. And we can use that and then verify various properties from that response. To do that, we implemented a little stack matchers is a little matcher library in Python that allows us to essentially test the output from the sort of describe stack endpoint. So the fixture here will just go and retrieve you the output of that describe stack call, and then we have various kind of matches like has a resource or has output or has parameters or has a status, for example. It's fairly similar. That's available for use. It's up on our Financial Times GitHub. However, what that doesn't do is it doesn't allow you to drill down into sort of the deep properties of a particular resource. So the response you get from the describe stack is very much, it's just it's kind of the top level. I created a bucket with a particular name, or I created an EC2 instance, and here's the ID. That's kind of what it gives you. So testing at that level is kind of give you cursory coverage. Inspect2 is a kind of auditing and compliance testing framework from Chef. And it's sort of an RSpec-based framework, and they released Inspect2 this year, and there's support for a bunch of AWS resources in there, so you can do some quite neat testing of those resources. So they've got some out-of-the-box sort of, it should, in this case, a CloudTrail should exist, it should be encrypted, and then you can also verify particular properties in quite a neat way. So we beginning to use that quite heavily in terms of, and actually it's sort of almost supplanting our stack matcher library in terms of how we're testing stuff now. It supports a bunch of resources. It's obviously not the full set of AWS services, but it's a good base. So the usual suspects, IAM, EC2, VPCs, etc. We're kind of using this quite heavily now, and actually we're thinking of turning it more into moving it on from just a testing framework to being more of an account health checking type solution as well. The third step in the pipeline was around publishing, and essentially we just use S3 as an artifact repository in much the same way you'd use something like NPM or PyPy or whatever to publish your software artifacts to. We just use an S3 bucket to publish our modules to. And we just have a simple object prefix convention where we have the module and the module version prefixed onto all the kind of assets we're pushing as part of that particular release. So in essence, we have Cloudformation templates plus Lambda source code plus our test assets in a repo. Any changes to that repo trigger an instance of our pipeline. We validate the templates using CFN-lint. We do the testing by deploying those stacks out to a sandbox account. We run various testing tools against that using stack matchers and inspect, and then we publish a version of that in those modules out to S3. So we have our sort of building blocks for our accounts, and now we need to figure out how to actually compose those together to essentially build out this sort of base configuration we layer into our accounts. So a topology for an account might look something like this. So we have some modules which we deploy to regions, and some modules that we deploy in a sort of singleton nature that's effectively global. So an example would be the sort of setting up our federated SSO. We stand up a bunch of roles and a SAML provider, and then we just do that once, whereas some of the other modules, like a VPC, would deploy on a per-region basis. Different accounts have different topologies. Some accounts are single region, some are multi-region, some require VPCs, some don't. So the kind of topology is not quite bespoke. There are some sort of almost profiles that accounts have, but there's certainly different variations that we see. And so the way we do this is we have this concept of a stack definition. A stack definition essentially references a particular module, and then says, I want to deploy that module into a particular region, and here's some module-specific config that I want to use when I'm launching those templates. There's nothing fancy. It's a simple YAML file, basically a template path that references a template from a module and a collection of parameters, essentially. So in this case, it's setting up a standard VPC from our VPC module with some properties, the name, and some side ranges. So an account effectively looks like it's just a collection of these stack definition files, plus something called a module manifest, which I'll just get onto in a second. So we lay out our accounts a bit like this. So at the top level, the kind of first level of the hierarchy there's the module, then we have the regions, and then we have the stack definitions that we want to launch. So in this case, we have an account where we're deploying a standard VPC into EU West 1, a standard VPC into US East 1, and there's some other sort of stack definitions that are setting up our connectivity to our data centers. And essentially, there's just lots of these stack definitions in the file, and each one will contain the peculiar config for that module in that region in that account. The module manifest is effectively the equivalent of a requirements.txt file in Python or your package.json file in Node. It's just essentially specifying what versions of the modules we depend on. And so our account pipeline, so any changes to either the stack definitions or our module manifest will trigger an instance of this account pipeline. We will first go and retrieve the versions of the modules from S3, pull them into the kind of the working area for the pipeline. We'll then do some validation on the stack definitions, so making sure that the template paths referenced in those stack definitions line up with the modules we've pulled in. We'll also check the parameters line up, and we haven't omitted any or got extra ones. And then we'll go ahead and deploy the stacks to our target account. So the deployment is where it gets a bit interesting. So the way we do that is we have a single account for deployment. We use GoCD as our continuous delivery server. And the idea being that we want from there to deploy those stacks across into another account. To enable us to do that, we have a deployment role that we bootstrap into the target account when we sort of stand up the empty account. That deployment role has the associated policy that allows the Cloudformation stacks to launch all the resources it needs. And it also has a statement that says, allow our continuous delivery server to essentially assume that role. And so when our continuous delivery server has a kind of a deployment for a particular account, the first thing it does is assume the deployment role from the target account, and then carries on and essentially runs through all the stacks and starts to deploy them. So multi-stack deployment. So you can do this with a bit of scripting, but there are some frameworks out there. Cloudformation has stack sets. They launched about a year ago. It's evolving. We happen to use Sceptre largely because stack sets didn't exist when we started this work. But also Sceptre has a number of features that I think stack sets needs to catch up with. Sceptre's from a company called CloudReach. They're sort of a big sort of cloud consulting group. And effectively, Sceptre, the command line has this command launch environment, and it essentially finds all the stack definitions that are located under a particular folder path, and then we'll go ahead and launch them for you. So it takes away any of that scripting pain. But it also has some other nice features. So it kind of has, by nature, it kind of forces you down this road of separating your kind of stacks and your stack configuration. It handles that switching to the deployment role for you, but you just simply configure the role you want to switch to within the Sceptre config. And it also does dependency resolution for you. So the way it does that is quite neat. So in your stack definition, you can effectively say, I've got a parameter, let's say it's the VPC ID, that I need to resolve from another stack that's been deployed. And so you can say, okay, there's a syntax that you can say, okay, get me the stack output from this other stack and inject it as the parameter into this stack. Once it knows that, it actually can work out essentially the dependency order and can work out the order in which to execute the stacks for you. So where it can, it will execute stacks in parallel. Where there's dependencies, it will put them in series. So it's quite a nice feature that actually if you were to code that yourself, it would be reasonably involved. It also has a nice little feature which we take advantage of, which is support for running code as hooks before or after stack executions. So most of the time we don't need this, but there's a few occasions where we're kind of maybe calling an API or something like that to configure something. We'll utilize this as well. So just in summary, that the account pipeline, we kind of said we have the source repository containing the stack definitions, the module manifest. Any change to that will trigger the account pipeline or a new instance of the pipeline. We'll go ahead, retrieve the various versions of the modules. We'll validate those stack definitions against the modules that we've pulled in, and then we'll deploy them with Sceptre to our target account. So the last section is about management of many AWS accounts. So one question, once we got to about 10 or 12 accounts, we were starting to hit this problem and say, we don't quite know what we've deployed where. So initially, we just essentially scraped all the manifest files and basically built a simple dashboard. On the left-hand side, we have our accounts. Across the top, we have our modules and all the version numbers essentially deployed out. And you can see there's some gaps where modules haven't been deployed to certain accounts. And on the right-hand side, we've just got a visual clue that the version of the tagbot module in this case is just a bit behind the latest version. So it's quite useful when you're kind of rolling out a module to many accounts to know where you've rolled it to, because we tend not to do everything at once. We tend to kind of phase the rollout. So we use this quite frequently when we're kind of staging rollouts of modules to our accounts. And that really is kind of a typical bread and butter kind of use case that we do every day, every week. So a new version of a module will come along, and then we will have to roll that out to all our accounts. And really what that is, for one account, is we just bump the version number. So typically that's all we have to do, as long as the module is effectively backwards compatible. On occasions we add in new parameters, and that's quite involved because you have to go through every account and add in some additional parameters into the stack definitions. But typically it's just bumping a version number. However, doing that across sort of 50 accounts is just torturous. So we wrote some tooling that allows us to effectively say, okay, can I deploy a new version of a module to one account, some accounts, or all accounts? And this is a bit of Slackbot integration that we use. And effectively, what's that doing behind the scenes is talking to the GitHub APIs, finding the relevant accounts we have, doing some validation to make sure the account exists, the module exists, the version exists, and just bumping that version number in those module manifest files. So we use this all, day in, day out. This is kind of how we push new modules. It also has the advantage that it's in the team channel, so everyone knows what's going on as well. So that is pretty much it. So I'll just kind of wrap up. In terms of what we're managing in source control, we have repos for modules, where we're managing Cloudformation templates, our Lambda source code, and test assets. For accounts, we have our stack definitions on our module manifest, and a stack definition is where we say, I want to deploy a module to a region with some peculiar config for that region and that account. And then our pipelines, we have So for each module, we just validate, test, and publish. So validating, we're validating with CFN lint. Testing, we're using kind of our own homegrown stack matcher library and also in Spec2. And publishing, we're just pushing up to sort of S3. And for our account pipelines, we've got this collection of stack definitions and the module manifest. Any change to those triggers a new instance of the account pipeline. We pull in the modules, we validate the stack definitions against the modules, and then we deploy the stacks with Sceptre. So that is it. Hope that was interesting. Thank you very much.